GitLab is the faster path from idea to software. It's more than a code repository. It's one workflow that brings development, security, and operations teams together. No walls, no endless feedback loops. Use GitLab end-to-end or integrate it with the tools you love. And it lets you eliminate the rest to help reduce costs and boost productivity at the same time without trade-offs. With GitLab, teams can build software faster, automate software delivery, shorten cycle times, and increase developer productivity. And security is built in, not bolted on. Scan for vulnerabilities with every code push, automatically. It's the entire development process, all in the same place where everyone works. Because we're on this path together. The path from idea to collaboration to higher performing teams. With one comprehensive, innovation-driving, fast and secure DevSecOps platform. Software faster. GitLab.
Okay, let's jump in. Thank you everyone for joining us. We're excited to go through today's content. My name's Taylor Lund. I'm a manager of customer success engineers here at GitLab, and I'm joined by Steve Graham, who is one of our customer success engineers. We're excited to hear from him today. Before we jump into the content of advanced CI/CD, just a couple of quick housekeeping items. First off, this webinar is being recorded, so you can look for that to come through into your inbox here the next day or so. Additionally, if you have any questions that come up throughout, please feel free to put those in the Q&A portion of Zoom, and either Steve or some other customer success engineers that are on the call today will be able to get those answered for you. And with that, I will pass it over to Steve.
Thank you, Taylor. Again, my name is Steve Graham. I'm a customer success engineer on the Scale team here. So let's go ahead and dive into our content today. Bear with me for just one quick minute while I rearrange a couple screen elements. Okay. All right, looks like we're good to go. All right, today we're going to be covering advanced GitLab CI and CD. Now, just for awareness, this particular session is really a good collection of what I would consider to be pro tips for optimizing GitLab CI and CD and for getting everything that you want to get out of it. So let's go ahead and dive into our content today. So this is our agenda. We're going to talk about CI and CD basics and do a quick review there. We're going to talk about pipeline structures and ways that you can hack that to set up different kinds of scenarios. We're going to be talking about variables, which is the foundation that you need to understand before you start using rules. And then we're going to talk about controlling when your jobs run using the rules keyword. Now, we're also going to talk about holding, securing, and sharing results with job artifacts. And then we're going to talk about assembling pipelines from components using includes and the extends keywords. So just a real quick overview. This workshop assumes that participants are familiar with basic GitLab CI and CD, and it presents advanced concepts and techniques for people who are active users of GitLab CI and CD, but we're not going to cover runner configuration or any of the CD-specific features such as environments or deployments. So just for awareness, those are out of scope for today. So first, let's start with GitLab CI and CD basics and just go through a quick review. This is an idealized workflow. It is exactly the one that we use here at GitLab, so just for awareness. But in this particular workflow, you might start from an epic that has milestones associated with it, and then spawn issues for different kinds of work that needs to be accomplished in your code base. And then once the issue gets assigned to a developer, they can create a merge request, which, by the way, can be created right from the issue itself. And when they create that merge request, they get a suggestion for a branch that they're going to create to go ahead and put their work into in GitLab. And then then following that, they would go ahead and perform their work, push their code in. And every single time that they push their code in, they're going to get an automated test, assuming that you've got pipelines set up. And then, that gives them the ability to do some scanning, do some testing for different types of scenario, make sure everything passes. And then, following that, they can go through collaboration and review. You might want to do a code review with other peers on the team. And then if they need to, they can push additional code in to fix things that their peers might suggest. And then that would go to a review app. And then once that's approved, it would be merged into the main or the master branch, whatever you've got there. And then that would subsequently launch a CD pipeline that would release this and then deploy it as you see fit. So GitLab CI/CD, this is a basic representation of a pipeline. You're writing code, you're committing it. You might go through some iterations on the code, and then you're going to go through a build, a unit test, integration tests. And then following that, once you're done with that, that might be an opportunity to package if you've got to package something up, maybe a container, or maybe you write an actual package for an operating system. And then following that would be a CD pipeline that would go through review. If you have a staging environment, it could go to staging and then production. So anatomy of a GitLab CI/CD build. This is just going to talk about some of the keywords we use here. Pipeline is a set of one or more jobs, optionally organized into stages, which we'll be showing you more of as we go. Stages are collections of jobs to be run in parallel. You might have a build stage, you might have a test stage, and you might have a deploy stage. And then all the jobs that are in each one of those stages kind of fits that categorization. And then jobs are scripts that perform tasks, whatever that needs to be. And then environments are where we deploy. This could be a test environment, a review environment, staging, production, whatever it needs to be for you. So next, let's talk about pipeline architectures. So the building blocks of your pipeline, we've got the basics, we've got directed acyclic graph, which is an advanced feature that you really should be leaning into if you've got, advanced dependencies. We've got parent and child pipelines, which are a great way to spawn additional pipelines that are independent and separate from the pipeline that you're running if you need to for some reason. We also have dynamic child pipelines. You have the ability to actually write YAML code in the job itself and then leave it as an artifact, and then that artifact gets picked up and launches a child pipeline. And then we also have multi-project pipelines, which are very popular with projects who have taken, let's say, a monorepo, broken it out into its various components. This is a way for different projects to launch pipelines in, an upstream or a downstream project. So in basic pipelines, this is the simplest pipeline in GitLab. Jobs run independently, sometimes on different runners. And by the way, if you're using shared runners, they're just about always going to run on different runners. All jobs at a stage have to complete successfully before proceeding to the next stage. And you can control the pipeline with pipeline options, which we're going to be getting into more of. This is an example of a simple pipeline here. As you can see, we've got 3 columns here, and those correlate to our stages. So we've got a build stage, we've got a test stage, and we've got a deploy stage. And each one of those has got its own jobs in it. So let's go ahead and move on from here. Now, test B here, by the way, if a job fails in a normal pipeline configuration and you have not set this allow failure to be true, it's going to stop the pipeline. You're going to get a red circle with a red X in the middle of it. And it's going to stop the pipeline. Any subsequent jobs are not going to fire up. So this particular job, there's going to be cases where you have test jobs that you want to be able to go ahead and finish the pipeline, but you want to be able to go back and review what that test job failed on or what component it had a problem with. And so this just gives you a way to do that quickly. And then notice that this deploy job has a play button on it. This is a manual job. Somebody has to be able to go in and click on the play button. And by the way, the default is that person has to at least be a developer in the project. But it is possible using protected branches for you to set specific people or specific groups that are allowed to deploy that job. And then some other options for the when. So again, the manual job is using when manual. Other options would be delayed on failure as an option, which is an obscure option. But if you've got a job that fails somewhere, you might want to fire up a job that does some inspection or tries to figure out what went wrong. And then when always, the default for these jobs is when on success, by the way. When always means even if there's a previous job that failed and wasn't allowed to fail, this job is going to run anyway. Now, again, jobs run independently, sometimes on different runners. All jobs in a stage have to complete successfully before proceeding to the next stage. So in this particular case, we've got a build job in the build stage. It has to complete before test A and test B can run. And then once test A and test B start to run, they have to complete before deploy can run. So this is just the sequential nature of stages. Now, next, I want to talk about needs or directed acyclic graph. This is a way to define job dependencies to optimize pipeline flow. There might be cases where a job only has very specific requirements, and it's actually eligible to run as soon as your pipeline fires up. And so there's ways to optimize for that. Jobs still run independently and sometimes on different runners, but dependent jobs can proceed to next stage without waiting for other jobs in the stage to finish. So let's go ahead and start walking through that a little bit. Now, in this particular case, you can see a pipeline on the left. The lines drawn between them are dependency lines, by the way, and they're relatively easy to read here in this particular simple pipeline, but they can get very, very complex, so just be aware. And by the way, this is if you are looking at a pipeline and you click on if you're editing your gitlab.gitlab-ci.yml file and you click on the Visualize tab at the top, you'll be able to see this. In this particular case, the iOS test doesn't have to wait for the Android build to complete. So this project has an iOS build and an Android build. And the Android test, in the same fashion, doesn't have to wait for the iOS build to complete. As soon as the Android build is ready to go, the Android test can fire up, and the same for the iOS test with the iOS build. Your jobs are still running in stages, but they no longer need to complete successfully for jobs in the next stage to begin. And you can see some examples that are shown in the code on the right. iOS build is running in the build stage. Android build is running in the build stage. And by the way, these jobs, anything that uses a colon at the end and is not a reserved keyword in GitLab's YAML structure is considered to be a job. So you can see that we're delineating a stage build for the first two, and then there's a linter test that runs in the test stage. And then in the iOS test, you can see that a needs is declared, and it's the iOS build. So it's dependent upon the iOS build job, and as soon as the build job is done, this job is now eligible to run. And the same thing for the Android test. Now, this is a fairly complex directed acyclic graph, which I should just call DAG to save some time here. But what you're seeing is the mouse rolls over the various jobs, is you're seeing the dependency trees that are involved in each particular job. So they can get very, very complex. This directed acyclic graph has the ability to do some fancy curving and whatever else it needs to do to connect these jobs. Now, another example of needs here. So the Linux path, the Linux RSpec job will be run as soon as the Linux build job finishes without waiting for the Mac build to finish. So notice we've got a Linux build job at the very top, a Mac build job right below that. And then the Linux RSpec job, it's going to run in the test stage, and then it needs Linux build. This is shorthand for writing an array. Instead of writing it long form with dashes down below, you can just put it, in between brackets if you want to. So it's going to wait for the Linux build job to finish. And as soon as that job is done, this Linux RSpec job can run. And the same thing on the Mac RSpec job. It just waits for the Mac build job. All right, so an additional example here is needs with artifacts. Jobs that use the needs keyword must also define any artifacts they depend on. So in this particular case here, test job 1 downloads the build job 1 artifacts. And you can see that delineated under the needs. So needs dash job that is dependent upon build job 1, and then the artifact statement below it says true. So we need to have that artifact in the test job 1. Test job 2 does not download the build job 2 artifacts. And you can see that it's dependent upon the build job 2, but it doesn't need the artifacts at all. So it's going to run completely independently, doesn't need the artifacts. And this will just save us a little bit of time for downloading the artifacts onto that next test job 2. And then test job 3, that job downloads the artifacts from all 3 build jobs. And this is because the artifacts is true or defaults true for all 3 needed jobs. So you can see that we've got the jobs delineated in 2 different places, build job 1, build job 2, and then build job 3 is just delineated all by itself down at the bottom. And again, artifacts defaults to true for these. So in that particular case, it's going to get all 3. All right, so next let's talk about needs and parallel matrix. Parallel matrices are a special setup that you can run in GitLab that allows you to set up, you can set up multiple jobs that have the same name, run on different application stacks. So you might have a Linux app, you might have a Mac OS X app, you might have an Android app, and you might have a iOS app all sharing the same repository, but they're all going to run the same name jobs. And so you can set up this parallel matrix this way. And in this particular case, the keyword allows needs to refer to a specific set of parallelized jobs. And you can see that delineated in Linux RSpec, where we've actually got the needs delineated there. So it's dependent upon the Linux build, and it's dependent upon the parallel matrix, the provider AWS, and the stack app 1. So this is an advanced usage of GitLab CI/CD, but if you've got the use case for it, definitely check this out and see how it can benefit you. Now, the next thing we're going to talk about is parent-child pipelines. Parent-child pipelines, they run independently from one another, but one triggers, the parent triggers the child pipeline. And then the parent-child pipelines are specific to pipelines that run in the same project. So it separates entire pipeline configuration into multiple files to keep things simple. So you might have a child pipeline with its own independent, whatever name file, .yaml file that you need to put it into. And then you can trigger that from a job in the parent pipeline. And then you can combine that with DAG pipelines to achieve benefits of both. And it's useful to branch out long-running tasks into separate pipelines. So in this particular case, you might have a separate job for a specific component inside your project, and that component needs to be tested separately, and it can run parallel with the rest of your pipeline. Now, parent-child pipelines look like what you're seeing right now. The pipeline you're viewing is this one that we're showing here on the left. And then you've got this downstream trigger point. And those are child pipelines. Now, it's not showing the jobs in the pipelines. You have to go to the pipelines page to see that. But it is possible to get the jobs in there if you use the depends keyword. So downstream pipelines are triggered from within this one. You just see each one as a represented pipeline. So parent-child pipelines for monorepos. In this particular case, we're going to run this job if there are changes in these files, and it's only changes in project-1 in that subdirectory, any files in that subdirectory. And then include files from anywhere in the project must reference a YAML file. So you can notice that build one is also a trigger job, and it's going to trigger this child pipeline. It's going to include the project file that it needs to run this particular pipeline. And in this case, it's using strategy depend, which means to hold this pipeline until the other pipeline finishes, but it also brings that pipeline's visibility back into the first one. So dynamic pipelines are a special use case. This might be the kind of thing where you've got a special test you've got to run, but there's no way to derive whether or not you know that test is going to run until you've run a specific job. And then you have the ability to write out the YAML, leave it as an artifact, and generate your configuration at build time. So you can use the generated configuration at a later stage to run as a child pipeline. And it's useful to use a single pipeline configuration with different settings to support a matrix of targets in architectures. And here's an example of a dynamic pipeline. So as you can see under the setup job on the left, we've got a script that's going to write into this file called generated-config.yml. And then we've also got artifacts delineated here, and the path is our file generated-config.yml. So this job is going to leave that artifact behind. It's going to get uploaded back to GitLab. And then we've got a trigger job right below it called test, and it's got the trigger functionality in it. It's going to include this artifact, and it's going to run this job setup and with the strategies depend. So we're actually referencing this artifact that we left behind that has dynamic YML in it in a later job that actually runs the trigger pipeline. Now, pipeline architectures, dynamic pipelines, again, if you go to, and if you haven't already done this, if you've been playing with GitLab pipelines at all, you know that you can go to the pipelines page, click on a pipeline, and then you have the jobs displayed in front of you. And if you click on a job, you go to the job log page, which is what you're looking at right here down on the bottom. So if we look at this, in this particular case, we can say that the replacement happened in the parent pipeline. It's running a dynamic pipeline by utilizing that artifact. Now, next I want to talk about multi-project pipelines, and this is a special use case. You might have a monorepo that you broke up into a bunch of different components just to make it easier for your teams to manage. And in this particular case, this gives you the ability for a pipeline in one project to trigger a pipeline in another project. You can specify a specific branch in the target project if you need to. You can pass variables to the downstream pipelines. And if a downstream pipeline fails, it will not fail the upstream pipeline unless you use the depends keyword. And this is useful when building and deploying large applications that are made up of different components that have their own project and build pipeline. So this is an example of a multi-project pipeline. In this particular case, you can see the trigger is constructed a little differently than it was in the parent-child pipeline. In this particular case, you can see that it's delineating a project, it's delineating a branch, it's calling out the strategy depends, and it's going to forward some pipeline variables. So the job with the trigger is referred to as the bridge job. Now, it doesn't have to have that name. It doesn't have to have the name bridge job, but that's what we tend to call it when we're using those types of pipelines. And it's possible to pass these environment variables downstream. So in your bridge job, any variables that you declare are going to get passed down to the multi-project pipeline by default. And then a downstream pipeline can be whatever you need it to be. So, again, you're going to see it as downstream, as a downstream pipeline in the stage that the trigger job is in. It's going to actually show up in a new stage that's going to emerge right right after that particular stage called downstream. All right, so next let's dive into variables. Variables are really important in that they're a foundational concept for using rules. So it's important to know where variables can be set at, where you can actually set them yourselves, and also to know what GitLab comes out of the box with predefined for you. So variables can be set at the group and the instance level. So if you're self-hosted, it's actually possible for your admins to create variables that flow down to all your groups and all of your projects. And as you can see on the screen in front of me, we have the ability to define a key and a value. And we can also protect that variable and mask that variable. Protect means it's only going to run on protected branches. And mask means that it's going to be masked in such a way that somebody can't echo it out in a job log. Now, variables can be entered on the pipeline run too. Now, in this particular case, you can see we're going to go to a pipelines page. I'm going to click on the run pipeline in the upper right-hand side. This is going to expose a form that lets us manually start a pipeline up. And in this particular case, we can pick a branch that we want to run it on. And then we can create a variable key and then variable value. And it'll let us create multiple of those if we need to. And then it's going to run that pipeline for us. Now, variables can be defined in your CI configuration file as well. And if you look at this particular file that we're seeing down at the bottom, the variables is a reserved keyword for GitLab's YAML files. And underneath that, it's got a variable called global var defined, and it has the value of test. And so if you look at this, you can see that the build job is defining a variable as well. And all we're going to do is echo it out. We're going to try global var on environment. It's going to be trying test on staging. And then it's possible to key into secrets as well. GitLab has a integration with Vault if you need to do that. Vault is the only integration we have for secrets right now, but this gives you the ability to key into Vault, set up the integration in advance, and then be able to rely upon access to those secrets as you're going through. In this particular case, we're looking for the production DB and the field password. And that gives us access to that particular variable as we need to, that secret. We also have the ability to have inherited variables. Now, these have got a certain order of precedence that needs to be understood, but it's possible for us to echo things out into a build.env file and then leave that as an artifact delineated as a report, and then again delineated as a .env file. And then that's going to be evaluated by downstream jobs that need to be able to run it. And by default, all the downstream jobs are going to get this this artifact. So that means that this particular variable is going to be defined in all the downstream jobs. Now, notice that in this particular case, build variable is the value from the build job. It's being dropped into the build.env file. The deploy job is going to pick that file up. It's going to get it automatically, and it's defining its own build variable value from deploy job. In this particular case, because of the precedence for these two variables being defined, inherited variables have precedence over job-defined variables. So in this particular case, we're going to be seeing the build variable from the build job and not from the deploy job. Now, GitLab has a huge number of predefined variables. And by the way, I put links in this particular slide so that you could go quickly to these and review them. I really suggest that you take time to go out and at least become familiar with what some of these things are that you think you might depend upon for setting up rules of your own. And then there's ones that are specific to merge request pipelines, and there's also ones that are specific to external pull request pipelines. So just be aware these are very good things for you to spend some time in. So variables are processed, and this is the order of precedence from least order of precedence to highest order of precedence, going from bottom to top. So values from GitLab, the predefined variables have the lowest precedence. Values that you declare in your YAML using the variables block have got the next order of precedence. Values inherited in jobs in previous stages, which is one that we just looked at a minute ago with the .env file. Those have got the next order of precedence, and then values configured at the project group or instance level have got the next order of precedence. And then there's values for this run. So if you go and you manually create a pipeline run and you put in variables there, that's going to have the highest order of precedence. And the same thing's true if you're using the API or if you're using scheduled jobs. So now let's talk about rules. So when are pipelines run? Pipelines are run for new commits, new branches, new tags, new merge requests, new pull requests. When you run them manually, you can trigger them with an API call, and you can trigger them with schedules. So you can pre-schedule pipelines to run once a week if you need to, something along those lines. And the basics on rules, you can see it defined here. In this particular case, we've got a job called only on web run. It's got a rules block defined below it. And then you can see that it's got a dash just below that. Rules is an array, by the way, and the dash is an array element. So in this particular case, if the CI pipeline source equals web, which, by the way, is a manual pipeline run. So if you go to the pipeline page and you click on run pipeline, that's what this particular value equates to. So if statements can reference variables, including the predefined ones, as is in this case, CI pipeline source is one of my most valuable predefined variables that I rely on a lot. And in this particular case, this job is only going to run when somebody goes to the pipelines page and manually runs a pipeline from the web form. So in this particular case, we're not using only, we're not using except, which, by the way, if you're using those now, I'd really encourage you to start diving into rules. They're a lot more versatile and give you a lot more capability of targeting specific scenarios. Now, the rules quick reference is just a list of things like clauses, operators that we can use. The clauses are if changes and exists. If is just an evaluation. It's exactly what you think it is. So we're just looking for something to be true. And if it is true, then that satisfies the if statement. Changes is the ability for us to look inside of a single file or subdirectory to see if there's any changes that have occurred there. And if there is, that can be combined with an if statement if we want to do that. But it can also be standalone if you need it to be. And then exists is kind of the inverse of that. It just looks for the presence of a file. And if that file exists, then that's presumed to be true. Now, the operators we can use, so this is between, like, when we're looking at a variable and we're comparing it to a value. Equals is what you think it is if you've been a programmer. It's just looking for parity between those two. Not equals, the exclamation point in equals just means that they can't be the same. So in this particular case, you're looking to make sure that a variable doesn't have a value. And as long as it doesn't, then that statement evaluates to true. Now, these two tilde operators that run right below that are equals and not applied to regex. So you have the ability to apply regex against things like your commit message or any of the other predefined variables that you want to look at. And then if for some reason you need to create more complex rules, you might want to evaluate one particular variable, make sure it matches a specific value, and then another variable, make sure it matches a specific value. and you want to combine those two into one. The and lets you do that, and then the or is the inverse of that, where either one of those can be true, and it'll then be satisfied and true. So results, we have the ability to dictate results using the when keyword, using allow failure, and start in, which is a special use case that we'll talk about in just a minute. When options are listed on the right. When is always, which means it runs unconditionally, whether previous jobs failed or not. When can be never, which combined with the rule gives you the ability to create a negative rule, right? So this is a case where you don't want this job to run at all. When can be on success, which is the default, by the way. You actually don't have to declare that. So on success just means everything that preceded this particular job either passed or was allowed to fail, one of the two. And then on failure is the special exception that we talked about previously. It's a job that can fire up when something fails and do some inspection. And then you also have the ability to declare when as a manual job, which again, it's going to give you a play button that somebody has to go in and click on the play indicator to fire that job up. And then delayed is a special use case that gives you the ability to use that results start in capability that you see on the left side of there. And delayed can specify that it's going to start in 10 minutes, 3 hours, and it starts counting down from the moment that the job is eligible to run. So rules quick reference. Let's go through this real quickly. Default values for when is on success, and for allow failure is false, which means that your jobs are going to stop your pipelines if you don't delineate when, because it's going to default to on success, and you don't allow failure true. So if some job fails, it's going to fail the whole pipeline. A job is added when a rule matches and has either when on success, when delayed, or when always. Either one of those will allow that particular rule to let that job fire up. The job is no match, but the last clause is, so this can be a standalone rule all by itself. It can be when on success, when delayed, or when always. You don't have to use an if statement. If you don't use an if statement, it's just in all cases, this is going to be the behavior. And a job is not added when no rule matches and there's no standalone when on success, when delayed, or when always, again, as its own separate rule. And a rule matches with when never, which is a case of our negative rules that we were talking about before, cases where you want to identify a circumstance that you don't want this job to run in. So rules example 1, in this particular case, we've got 2 rules delineated. If CI pipeline source equals merge request event, which by the way is a very good use of that particular CI pipeline source, or if CI pipeline source equals a push event, push to any particular branch. In this particular case, we're not delineating a branch, so it's just a push event, period. So in this particular case, we're going to get this job running when a merge request event is coming in or a push event is coming in, either one of those two. Now let's look at this next one. In this particular case, we've got when clauses defined. So we've got 3 rules defined here. The top 2 use if tests. So they're checking against pipeline source. Again, merge request event, and in this case, a pipeline source of schedule, which means you've gone in, you've scheduled this pipeline to run automatically once a week or once a day, whatever you want to do. And in those 2 cases, those are cases where we don't want this job to be included. So they've got a when never on them. And in those 2 cases, and by the way, GitLab is going to process rules until it hits a match. And as soon as it hits a match, it's going to stop processing any rules that follow. So in this particular case, if the CI pipeline source is a merge request event, then GitLab's going to know that this job doesn't get included. It's not going to evaluate any more of the rules. Same thing for scheduled. And then it's got a standalone when on success, which again, doesn't have to have an if statement on it at all. This just means if it doesn't match the first two rules, then this job runs as long as everything that preceded this job was successful or allowed to fail. Now, example 3, this job will not run if custom variable is equal to false. So in this particular case, we're looking at some custom variable that we created, and we're looking to see if its value equals false. And in that particular circumstance, we don't want this job to be included at all. But in any other circumstance, we always want this job to be included. So this might be a case where you're creating some custom variable based on some workflow rules or something along those lines that lets you set that variable for a special condition, and then this job's not going to run. Example 4, in this particular case, we're using changes, which you can say delineated in that top rule. And so in this particular case, we're comparing some variable to some string value. And then we're looking for changes in Dockerfile or Docker scripts. Now these get ANDed together. If and changes get ANDed together. And in this particular case, if there's changes in either the Dockerfile or the Docker scripts directory, and the if test true, then this job is going to be a manual job because when is manual in this particular case. We could have made it the default of when on success if we wanted to, or delineated when on success, and it would have just run automatically. And in this particular case, we're allowing this job to fail using the allow failure : true. So this job is going to run. This is an example of the delayed when clause. So we're first running a test to make sure that the commit branch is main. It could be master or whatever you need that branch name to be. And if that is the commit branch, then this job's going to be delayed. It's going to start in 3 hours. If you use when delayed, you've also got to use the start in directive. And in this particular case, we're going to start at 3 hours, and it's allowed to fail. So again, allow failure is true, which overwrites the default to false. Now, in this particular case, we can see the CI pipeline source is merge request event, and changes is looking in the Docker file exclusively. And we're going to compare that to refs heads branch 1. And if there's changes compared to that, then that's what we're going to be looking for. So this Docker build job is only included when the Docker file is changed relative to refs heads branch 1 and the pipeline source is a merge request event. Now, workflow rules are a special use case, but they're definitely worthy of your time and energy to dive into. Workflow rules are a global statement that you can put into your GitLab.gitlab-ci.yml file. They're not included in a job. And this is a case where GitLab's going to make a bold decision to either run any jobs that are eligible or not to run any pipeline at all. In this particular case, we're looking for the CI commit message, and we're using regular expressions here, as you can see, and we're looking for -draft. And if -draft is in that commit message at the very end, then we activate the when never clause. So it's not going to run in that particular circumstance at all. The other circumstance we don't want this to run in is if it's a CI commit tag. So we're just doing a simple if. If the CI commit tag exists at all, then we're not going to run this particular job or this pipeline or any pipeline at all in this particular project. And in all other circumstances, we're going to run a pipeline. So this is very useful because this is a way you might have jobs that are going to run under a whole lot of different circumstances, and this is a way to just shut pipelines down completely if you need to. But you can also decide to run pipelines based on workflow rules, and you can use workflow rules to define variables if you want to do that. So that's one of the places where it becomes very handy. And then in this particular case, we're looking at Docker file. And you can see that if the CI commit ref name has the word draft in it, then we're looking at using the Docker file. We're creating a variable called Docker file that's going to have the value of test.dockerfile. And if the CI commit ref name is the CI default branch, which might be main, might be master for your project, then in that particular case, we're going to create the same variable called Dockerfile, but it's going to have the value of main.dockerfile. And in any other circumstance, this is just always going to run a pipeline. So the top two are going to run pipelines, but they're going to change these two variables that you're looking at, this single variable, depending on what's coming in. And then in any other circumstance, we're just going to run a pipeline. All right, let's dive into artifacts. So GitLab allows you to save anything that you want to that's an artifact. In fact, most of our scanning tests will leave some type of report artifact behind, but you might have a build artifact you want to save for one reason or another. And GitLab has the ability for, if you delineate and prescribe what that artifact is going to be, GitLab's going to upload it back to GitLab when your job is done. And then that's going to be available to any subsequent jobs, because GitLab's going to download any artifacts created to every subsequent job. And you can pull this in any combination of paths or files. You can use exclude to limit what's added. You can use depends to limit what gets downloaded, which is an important thing to do. If you've got 10 jobs that are leaving artifacts and you've got one job that only needs one artifact from one job, then there's a way to delineate that using the depends keyword. And you can use when to determine if artifacts will be stored or not. And you can use an expire in, which is really important because artifacts can really build up over time. And if you're using GitLab.com, you've got limits on how big each project can be, and artifact storage contributes to that. If you're self-hosted, artifact storage can really get out of control, especially when you're storing build artifacts. And so using this expire in just gives GitLab permission to delete these artifacts automatically. And what you can see here is we're defining an artifacts job. In this particular case, we're defining artifacts in a job. This can be when on success. We're delineating the paths of bin/target and anything that ends in .exe. And then we're going to exclude throwaway.exe. And this artifact, any artifacts created by this particular job are going to expire in 3 months. You might want to make that hours, weeks, whatever just works for you and your team. And there is a way to subvert that, so just be aware. So 3 ways of accessing artifacts via secure HTTPS. You have the ability to reach directly into the job, download the artifacts. This requires having a personal access token that you can use and that has access to GitLab. You can use the build product for the latest pipeline run on a specific branch. In the case up at the very top, this is looking on a specific job, and you're going to get an archive file that has the artifacts from that job. And then the build product for the latest pipeline is going to download everything that's an artifact created anywhere by any job in the pipeline. And then all products as a zip for the latest pipeline run on a specific job or on a specific branch. So there's 3 ways of accessing those via HTTPS. Now, the other way you can do it is if you go to the pipelines page, where you've just got the pipelines listed single line per pipeline, you'll see that there's an ability to download your artifacts there on the right-hand side. Now, what you're going to get is an archive file that's going to have every single artifact defined by every single job in it. If you want to go to the jobs page, and then, this is a case where you've got each job delineated by a line, you're going to have the same type of capability there. Only if you want to download from there, what you're going to get is an archive file that's only got the artifacts for that specific job, not any other jobs, which is kind of convenient. And then if you click on a job and go to the job log page, you're going to have the ability to download it directly from the right navigation on the right side of the job. As long as the job is finished running and it created an artifact, you'll have this download capability. Now, notice that you've got a browse button there too. That lets you look inside the archive file and see what artifacts are in there. But also notice that there's a keep button on the left. So if you've delineated that you want this to be, you want your job artifacts to expire in 3 hours, and somebody needs to have other people review this artifact, they can click on keep and it'll be kept indefinitely. It completely defeats the expiring. All right, so in a self-managed GitLab instance, job artifacts can be stored in local storage or object storage. It's up to you. A lot of teams like to use object storage just because that's more controllable. They can add additional storage quite easily in object storage. And it's a whole different story if you're using local block-mounted storage. Artifact expiration times can be configured and given a default at the instance level if you need to do that, and you're self-hosted. And then artifact downloads fall under GitLab's access control. So if you're creating artifacts and they're potentially sensitive and you've got a private project, then the only people who are going to be able to access those artifacts are people who've been invited to the project and have read access. So nobody else is going to be able to access them. Now, if you make your project public, that's a different story. And then there's some additional settings you'll need to look into for the project itself. Now, dependencies is a keyword that we can use to delineate when we want to be able to get artifacts in a specific job, and only those artifacts. So in this particular case, we can reduce the number of artifacts passed from previous jobs. So if we've got 10 jobs running before the job that's going to run, and we don't need 10 artifacts coming in, assuming they all create one, then we can definitely use dependencies keyword to get the specific jobs artifacts that we need. In this particular case, if you look at test OSX, which is the third job down, you can see that it's got dependencies declared and it's looking for the build OSX job. And then test Linux is doing the same thing with the build Linux job. So if you follow the dependencies keyword with an empty array, which is just a square bracket open, square bracket closed, that'll skip downloading artifacts altogether. So if you've got a job that doesn't rely on artifacts at all, definitely use that dependencies keyword with an empty array so that those jobs can be eligible to run even quicker. And this is only from jobs from previous stages. So you're only going to get artifacts from jobs that were leaving artifacts in a previous stage. Now, we've got container and language specific registries. In this particular case, what you're looking at is the list of package registries that are available in GitLab. We've got a Docker registry at the very top, which is we just call a container registry. And then we've got a dependency proxy. So we've got the ability, GitLab will actually proxy any calls out to the main Docker registry maintained by Docker Hub. And because of that, GitLab has the ability to not make every single call go out to Docker Hub so that you can save some usage there. And then we've got that followed by some very language specific package registries. So if any of these are valuable to you and you're building packages this way, definitely think about putting these packages into the specific registries that we have for them. Now, next, let's talk about includes and extends. This is a way for you to include files from other locations to extend the use of your your pipelines. So include allows you to include a job from a different place. Allows the inclusion of external YAML files if you want to do that. It helps break down the CI/CD configuration into multiple files and increases readability for long configuration files. So you might have really, really complex pipelines, or you might have multiple independent pipelines that need to be able to run under different conditions. And you can use include statements to pull those independent pipelines with their files in and include them in your main pipeline file at runtime. So in this particular case, what you can see delineated down below here is we've got an include local, which is just the keyword that means, include this file that's in this particular repository that we're running this pipeline in. And then you have the ability to include files from independent projects. Now you've got to have read access. Whoever's running the pipeline has to have read access to this repository that we're delineating here with project and file. But that's a really cool way to be able to build template repositories for pipeline files. A lot of organizations have got very, very similar requirements for pipelines. And you might have a team, a DevOps or DevSecOps team that just specializes in building these pipeline files. And this is a way for you to pull them in and include them in your main.gitlab-ci.yml file. And then you've got this ability to include a remote file. Now, this is a very special circumstance. In this particular case, that file's got to be absolutely public because there's no authentication mechanisms built into this remote capability. And you're just going to give it a URL. But that might be something that you know about at GitLab.com that you just want to pull in and be able to execute in your pipeline. And then the last two that you see include template and template. This particular case is, these are jobs that ship with GitLab. So if you're self-hosted, they came with your version of GitLab that you're running on right now. If you're at GitLab.com, they're just built into the infrastructure that we have there. So those are specific to GitLab supplied files. Now, we have the ability to create input parameters for includable CI and CD templates. So just be aware of this. This is relatively new. We call it a CI/CD components catalog, but it gives you the ability to create the same types of things of your own. Now, by the way, the classic way of having templates pivot and change their functionality has always been to use project variables. But this gives us a way not to use up variable namespace and be able to do the same types of things. In this example, the template spec calls for two inputs, one required, which has no defaults, and one optional. So you can see that delineated in the included file on the right. And then the template file on the left, as you can see, has got website, which has no default value, and environment, which has a default value of test. And so that's going to be just built into anything that includes it. And you need to delineate those things in the same fashion you see being done down there at the bottom in the deploy stage. So extends is a special use case. It gives us the ability to extend a previously defined job. And that job can be either a running job or it can be a hidden job. And in this particular case, what we're looking at with the .test keyword at the very top left window there, the dot means it's a hidden job. So .test is a hidden job. It's never going to execute as a job. It's just there to be extended by other jobs if they choose to do it. And you can see that the RSpec job extends the .tests hidden job. And if you look at what this becomes, so realize that the .test hidden job has rake test as a script. The RSpec job has rake RSpec as the script. And then they both, in the top tests, it's only going to run on refs that include branches. In the bottom one, RSpec is only going to run if the variable RSpec exists. So in this particular case, what you can see is this creates a job that's a merging of the two. Now, in this particular case, RSpec is when we create the RSpec job, it has the ability to overwrite anything. Even though it's extending the .test job, it can overwrite anything that's already in existence on the .test job. And so in this particular case, since script is defined in both places, it gets the rake RSpec that is included on the RSpec job. But as you can see, for the only section, it's going to marry refs, branches, and the variables are RSpec. So we can use includes and extends together. It's certainly possible to have a hidden job defined in an included YAML file. And you can see that delineated here at .template. So in this particular case, you can see it being used on the right side there. So you can do the following. You can include the YAML file that has that job defined in it. And then in this case, we're going to call the job use template. We're going to define the image of Alpine. So it's going to run in the Alpine Docker image. And we're going to extend the .template file, which is just going to give us the echo hello in this case. All right, we're at the very end. I hope we didn't go too fast, but we had a lot to do today. So Taylor, do we have any questions?
Thank you, Steve. Yeah, due to time, maybe we'll just take one or two of these, and we can certainly follow up with folks if other questions didn't get all the way answered.
Absolutely.
One here, when should I use a child pipeline?
So child pipelines are a special use case, but if you've got a project that's broken out into multiple components, that's a really good use for child pipelines, because a child pipeline can run in parallel to the pipeline that triggers it. And it's not going to have to wait for stages to complete, things along those lines. So that's a good use case for child pipelines. It's just running on its independent component all by itself.
Great. Let's maybe do one more. Why do we use a pipeline in GitLab?
Pipelines enable a lot of other functionality. Now, one of the best things about pipelines is, we can see the status of any job that's in the pipeline. Maybe the build job fails, and you pull in a couple of other team members for a code review, and they find a problem in that particular job or with the code itself. But the other use case is, you might want to release this job out to production. You might want to put a manual release job at the end. And that just gives you a way to be able to manage that in the context of the same tool that everybody else is already in.
Great. Thanks, Steve. And if you wouldn't mind stopping your screen share, I was going to share a quick slide as well as I pull that up here. We seeing that okay?
Oh, yeah.
Great. So wanted to make everyone aware of some ongoing resources that are available to you as well. From our self-paced learning and certification, a private instructor-led training, as well as our monthly webinars, which you're attending today. Additionally, you have the ability to engage either a CSE or a CSM, depending on your account structure. This will be included in the follow-up that we send as well with these links. So we want to make sure that you are well taken care of moving forward from a learning and development standpoint as well. So that'll be included with the deck that we share. And with that, we will wrap up today's session. Thanks everyone for taking the time. Thank you, Steve, for going through the content, and hope everyone has a good rest of your day.
Thanks, Taylor. Yeah, we'll see you later. Bye-bye.